Okay, hi everyone. So today we're going to talk about intermolecular forces. Alright, so intermolecular forces are attractive forces that exist between molecules. Alright, so for example, between water molecule with another water molecule, there exists an intermolecular forces. Okay, so there are two main types of intermolecular forces, which is the first one is hydrogen bonding and the second one is van der Waals forces. Okay, so under van der Waals forces there are two further types of intermolecular forces, which is dipole-dipole forces and London forces. Okay, so the difference between these two is depending on the polarity. If the molecule is polar, that means it will have dipole-dipole forces between the molecules. If the molecules is non-polar, so it will have London forces. Okay, whereas hydrogen bonding is a special types of intermolecular forces which only exist between molecules that has hydrogen which is directly bonded to either fluorine or oxygen and nitrogen. The easiest way to remember is FON: fluorine, oxygen and nitrogen. And as you know, these three atoms is the highest electronegativity elements on Earth. Okay. Alright, so the reason why hydrogen bond only exists between hydrogen and fluorine, hydrogen with oxygen and nitrogen with hydrogen is because of the presence of lone pair on the fluorine atom, okay, on the oxygen atom and the nitrogen. Okay, so this hydrogen must directly bonded. Okay, the hint here that you need to remember, H, which has partially positive, must be directly bonded to fluorine or oxygen and nitrogen. Okay, the presence of lone pair around fluorine, around oxygen and around nitrogen causes this hydrogen to be extremely partially positive. Okay, so how does hydrogen form between these molecules? Okay, so between HF, okay, so this H will be partially positive and this fluorine will be partially negative. So this stroke line indicates hydrogen bond. So this H will be hydrogen bond with a fluorine atom of another HF molecules. Okay, so this one we name it as hydrogen bond. Again, even though it's named as hydrogen bond, it's just an intermolecular forces which you can break it by supplying enough energy to overcome the intermolecular forces. So it's not like a covalent bond or ionic bond that you can't break the bond. This one is just an IMF, intermolecular forces. Okay, so let me show you another example on how hydrogen bond is formed between water molecules. Alright, so in the water molecules there are two lone pairs, indicate these two hydrogen will be partially positive and partially positive. So means it can form two hydrogen bond with another two water molecule. Okay, so let's draw the hydrogen bond. Okay, so this one will form hydrogen bond with another water molecule. So H will be bonded with oxygen in another water molecule. Okay, so I have another H here. Okay, so this is the first water molecule. Alright, so next hydrogen bond. Okay, So, as you can see, the presence of two lone pairs on oxygen atom indicates we can have two partially positive hydrogen, okay, extremely partially positive H+, which means both of these hydrogen are available to form hydrogen bond. Okay, so now let me show you for nitrogen or in ammonia. Alright, so in ammonia, there is only one lone pair on the nitrogen atom, means it only have the ability to form only one extremely partially positive H+. So there are three hydrogen atoms. You can choose either one. So since only one lone pair, so only one hydrogen will be extremely partially positive. So that means only one hydrogen will have the ability to form hydrogen bond with another ammonia molecule. So let me show you the formations of hydrogen bond in ammonia. Alright, so this another two hydrogen atom will never form H bond, okay, with another NH3 molecule. Okay, why? Because only one lone pair is present on an atom. So that's why ammonia can only form one hydrogen bond. So we label here again for you to easier for you to understand. So this dashed line is referring to hydrogen bond. Okay, so these three molecules, as you can see, hydrogen fluoride has only one H atom. Okay, even though it has three lone pair, but hydrogen fluoride only has one hydrogen, so that means it only can form one hydrogen bond. Okay, in the water molecules, two lone pair is present on your oxygen atom, and it has two hydrogen atom, means it can form two H bond. Okay, and NH3, okay, it has only one lone pair on nitrogen atom, and therefore, even though it has three hydrogen atoms, it only can form one hydrogen bond. Okay, so let's say we need to explain the trend in boiling point between these three different molecules. You're going to expect initially, since fluorine is the most electronegative atom on Earth, followed by oxygen and nitrogen, you're going to expect HF has the highest boiling point, followed by H2O, followed by NH3. So these are expectation, or in other words we can say is our prediction. Okay, so increasing boiling point. Okay, however, it's not the same like that. Why? Besides the electronegativity also contribute to the strength of hydrogen bond. Okay, so the strength of hydrogen bond also contributed by the number of hydrogen bond a molecule can make. Okay, so as we draw initially in the picture above, HF can form one H bond. Okay, water can form two H bond, and ammonia can form only one H bond. Alright, so the trend in the boiling point is slightly different for hydrogen fluoride and ammonia. So reality, you're going to see water has the highest boiling point, followed by hydrogen fluoride, and ammonia still in the third ranking in the trend of boiling point between these three molecules. So these are the reality. Okay, so if you need to give a reason why does water have the highest boiling point between hydrogen fluoride and ammonia? So you need to mention that water can form 2 hydrogen bond with another 2 water molecule. Alright, so it have the highest or strongest hydrogen bond in the molecular forces compared to in HF and H3, which only can form 1 hydrogen bond. Okay, that's all for your hydrogen bond. Okay, so the effect of hydrogen bond. No, I'm going to talk about the strength of IMF in H bond. Okay, is only affected by first either fluorine or oxygen or N. Okay, which one is the most electronegative? And secondly is about the number of H bond it can form. Okay, as we talked earlier just now, there are 3 types of intermolecular forces: hydrogen bond, double forces, and London forces. Okay, if we are going to ranking these 3 types of intermolecular forces in the terms of its strength, okay, provided they are having a similar size of molecule. Similar size means they are roughly having same molecular weight. Okay, so hydrogen bond is the strongest, followed by dipole forces, and lastly is London forces. So this one we label is increasing strength of IMF. Okay, but if it's in the different size, okay, so means different molecular weight, and the molecular weight difference is too big. Okay, so hydrogen bond is still the strongest. Okay, but between dipole forces will depends on the molecular weight.